Good day everyone. So today I will be talking about reinforced steel, and under reinforced steel is the bar marking. So let's start. Most people are familiar with reinforcing steel, or commonly known as rebar. It is used in bridges, buildings, skyscrapers, homes, warehouses, and foundations to create the strength of a concrete structure. So, what really is reinforcing steel? So, reinforcing steel, commonly known as rebar, is used in concrete to provide additional strength as concrete is weak in tension, while steel is strong in both tension and compression. So, steel and concrete have similar coefficients of thermal expansions. So, a concrete structure member reinforced with steel will experience minimal stress as the temperature changes. So, reinforced steel, or what we call is the usually it just called steel. So there are four types of reinforcing steel. So what are those? So first is the hot rolled deformed bars. So hot rolled deformed bars are most commonly used steel reinforcement for RCC structures. As the name says, the hot rolling of the reinforced is undergone, leaving certain deformations on its surface in the form of ribs. So these ribs help to form a bond with the concrete. The typical yield strength of hot rolled deformed bars is 60,000 psi. So this is you can see the picture you can see there is the sample of hot rolled deformed bars. So next type is the cold work steel bars. So a cold work reinforcement bar is obtained by letting the hot rolled steel bars to undergo cold working. In the cold working process, the bars will undergo twisting or drawing. The process is performed at room temperature, as it is cold. The cold work steel bars do not undergo a plastic yield, thus have less ductility when compared to the hot rolled bars. So from hot rolled bars, it is undergo a cold working, so it is now called the cold worked steel bars. So to continue, the third type is the mild steel plain bars. So the mild steel plain reinforcement bars do not have ribs on their surface. They have a plain surface. These bars are used for small projects where the major concern is the economy. The tensile yield strength of these bars has a value of 40,000 psi. So they uses these bars so that they can um, save less, save more money, and and it's only used for small projects. So the last one is the pre-stressing bars, or pre-stressing steel bars. So the pre-stressing steel reinforcement are steel bars used in the form of strands or tendons. So multiple strands are employed in concrete in order to perform the pre-stressing action. The strands are made of multiple wires, either 2, 3, or 7 wire strands. The wires used here are cold formed and have a high tensile strength ranging from 25 to 250,000 to 270,000 psi. This high strength helps to effectively pre-stress the concrete. So these pre-stressing steel bars are wires which made out of 2, 3 or more wire strands, and it's rotated to each other to form this bar. Why need for steel reinforcement? So we all know concrete is lesser in tension, and strong in compression. So, tensile property for concrete structures is obtained by incorporating steel reinforcement. The steel reinforcement is strong in both tension and compression. The tensile property provided by the steel reinforcement will prevent and minimize concrete cracks under tension load. We can say that the importance of steel reinforcement in concrete is much higher, because without steel reinforcement, our concrete can be easily broken. So steel and concrete is, when mixed together or when they are being put together, they provide much strength and can last for more years and decades. So, what are the advantages of steel reinforcement? Steel reinforcement is a reinforcing choice compared to other reinforcing materials due to its unique advantage. So, they are: steel reinforcement does not demand special tying up with formworks. So, compatibility with concrete. So, how can we know that the reinforcing steel is compatible to the concrete that we are using? So, the fresh concrete is based on the formwork mold already prepared with reinforcement. The steel reinforcement won't float in concrete during the concrete placing procedures. Next advantage of steel reinforcement is the robustness. So, knowing that the steel reinforcement are robust, it can withstand any weather or wear and tear. Continue, we have bend property of steel reinforcement. We all know that the steel reinforcement is bendable. That's why it is for the constructor to easily use it. Next property is the recycling property. So, from the types of steel bars, we have sometimes the steel bars are being hot rolled or set into a high temperature so it melts before use a cold working, which it go back to its original shape. So it is possible, or it is one of his property, to be recycled. Another one is the easily available. Every region of country will have a steel supplier or manufacturer. Hence, steel reinforcement is commonly available or easily available. So, everywhere you can see or you can find steel bars or steel reinforcement. So, next is the disadvantages of steel reinforcement. Even though there's a lot of advantages, there's always there will always be disadvantages. So the main disadvantages of steel reinforcement are mentioned below. So the first a disadvantage of steel reinforcement is the reactive nature of steel reinforcement. So when the steel bars or steel reinforcement are being exposed to any moisture or actions that it is not covered with concrete, there are this chance of corrosion or corrode, and finally to failure. It's expensive and melts at high temperature, so the cost of steel reinforcement is high. This will increase the cost of construction. So, knowing that the steel reinforcement are expensive, usually constructor find the cheaper steel reinforcement, and it affects the construction or the building they have constructed, so it can't last longer than expected. So next is the melt of high temperature. So at high temperatures, the steel reinforcement may melt. So this is the reason why the steel reinforcement are tied up and not welded. So knowing in construction, we know that steel bars are being tied up, and they don't use welding in connecting steel reinforcement. because it melts. Scale, rust, oil, and mud. So these four impacts the reinforcing steel. In scale, it is a material found normally on the bars that is produced at the time the bars are manufactured. So for the rust, actually improves bond because it increases the roughness of the surface. So much rust that the weight of the bar is reduced, or the height of the deformations is reduced to below the weight area or deformation required by the application ASTM, then the rust is considered harmful. So for the oil and mud, if oil and grease get into the surface of the bar, it must be cleaned off. And finally, for the mud, you should load and unload bars to avoid getting them covered with mud. So any mud on the bars need to be washed off before using the bars. Steel reinforcing bars are also called as rebars. We all know that. So it is used as a tension device for concrete constructions. It strengthens and aids the concrete under tension, since concrete is known to be strong under compression yet weak in its tensile strength. So those ribs we found or we have observed in reinforced bars, usage of that is to avoid slippage and also reduce the risk, and it increases the tensile strength of a structure. Here we have the production of rebar. So we already studied about the basics of rebars. Now we will talk about how first step is to melt either steel, carbon, or alloy. So when they are under liquid form, with the help of the extreme amount of heat, they are being reshaped, or what they said here is a small round openings to give its shape. So for the second step, we have here, usually for rebars, they uses epoxy coated or stainless steel. But then, because developers wanted a profitable and a safe for long-term usage, they chooses to use a high-grade materials instead. So the third one is, once the steel has been properly shaped, the manufacturer will make the twists and grooves on the metal to ensure it will stay firmly in place inside the structure. So fourth one, since these reinforced metal bars are highly hazardous when it comes to installation, their ends are often covered with plastic cups to prevent accidental harm to construction workers. So as we have observed, usually rebars has a cup in both ends, or plastic cup in both ends, to prevent any harm or danger to the user or construction workers. And lastly, we all know that rebars are not welded or cannot be welded. So here they said that usually they utilize, or the construction companies utilize, wire and coupling splices. We have the bar markings. So bar markings are very essential to engineers so that they can identify what kind of bars or rebars they are needing for the construction. So there are many ways to identify reinforcing steel bar, from the production mill to the fabrication shop to the job site. So Some rebars have the same appearance that leads to some people finding it hard to identify the rebars themselves, which may cause mistake easily. So this is the main reason why we have markings or bar markings, so the people cannot be confused of what they should get for their construction or any project or they need rebar. So here is the sample of um, the symbols or markings in the rebar. So let's explain this further. So it is rebar marking is based on ASTM, or has been tackled beforehand. So each individual reinforcing bar is manufactured with a series of individual markings. So here is the example. So always is this. The first letter or symbol identifies the production mill and its deformation pattern. So here we have the main ribs, the point of origin. This point of origin is the letter or the symbol of producing mill. So we have here the H. And then the next marking is the bar size. So it is about the bar diameter and length. So here we have 10, which is size 10 or number 10, hashtag 10 usually. So here we go back to our first photo. Here we have bar size number 11. Here we have number 11. Then on the next slide we have number 10. Then we also have its type of steel and the grade mark or line. The next slide we have the third marking symbol signated the type of reinforcing steel that usually either S, W, SS, R, I, A, and CS. So these letters usually being marked on the rebar to let us know what type of reinforcing steel being used. So for S, it is for carbon steel, W for low alloy steel, SS for stainless steel, R for rail steel, I for axle steel, A for rail steel, CS for low carbon chromium. So this is all based to ASTM. And then for the last marking symbol we have the grade of reinforcing steel. So usually we have 40, 60, 75, 4, and 5. So 40 or grade 40, usually they didn't put that. They only put 60, which is for grade 60, 75 for grade 75, 4 for grade 420, also grade 60, and 5 for grade 520, also grade 75. So this sample picture shows us how bar marking is being put there. So there are this first bar we have 3 symbols. The second bar we have 4 symbols. So usually it is because of the grade. So usually the grade 40 below or 40 is not being marked because usually the grade 60 is the only sorted only at grade 60. So the first letter is, again, it is a letter or symbol to produce meal. Next is the bar size. Next to the bar size is the steel type, which is S for carbon steel, and then the grade, which is 60 for the second bar, which is grade 60. So, have here the grade line and the main ribs. So that's it for this um, report. So I'm hoping that you all have learned something, and thank you for watching.